that you're more familiar with how to create your project in Collectors Online, let's take a look at some of the things to consider when interpreting imagery and collecting data in CEO. So in this video, we're going to take a look at the 7 different image characteristics that we as humans use to interpret imagery, as well as some helpful tips to help you when you start collecting your data. So these practices are drawn from the Collectors Online official documentation, as well as some best practices that were documented by Severe after countless projects using Collectors Online. So the first image characteristic that you're going to use when you interpret imagery is pretty intuitive. It's the tone and color of the image. So tone refers to the brightness of a black and white image, and color refers to the different hues that appear in that image. So we're most familiar with true color imagery, which is shown on the left, which is similar to what our eyes perceive. But we can also use false color imagery, which we covered a little bit in Unit 2, where we're assigning non-optical light to a specific primary color. And you can see an example of that on the right-hand side of this slide. So this is the same scene in both true color and false color. And so pretty naturally, you're going to use the different colors in this image to identify different land cover classes. So in the true color image on the left-hand side, we see those grays and browns, and we know that that's probably an urban area. We see those deep greens, and we associate that with vegetation. And for those lighter tan areas, we know it's most likely bare ground or cropland. And of course, when we're actually interpreting imagery for our assessment units, we'll zoom into a much higher resolution. Another image characteristic we can use is size, which is really helpful in distinguishing between two land cover classes that have a similar shape, as well as a similar tone and color, such as trees and shrubs. So in this image, we can notice that on the left-hand side of the white line, the vegetation here has a much larger size than the vegetation on the right, even though it appears very similar in other image characteristics. And another helpful image characteristic that's very related to size is shadow, because we can use the size of the shadow to estimate the size of the land cover class that it is associated with. So we can see that on the right-hand side of the image, we don't see a whole lot of shadow except for towards the upper right part of the image. And we notice that all of these shadows appear to the left of these larger pieces of vegetation. We can also see those shadows on the left-hand side of the image, again, all occurring to the bottom left of the objects that are throwing that shadow. So we can use those characteristics to come to the conclusion that there are trees sprinkled in this area of shrubland here on the right. Another image characteristic that we will use is texture, which refers to the apparent roughness of an image. And this can be especially helpful when distinguishing tree species or crop species from one another. So in this particular image, we can see within this polygon here, this vegetation is displaying a very fine texture, whereas the vegetation on the outside of that polygon is showing a very coarse texture. Another image characteristic we can use is pattern, and pattern refers to the arrangement of individual objects into recurring forms. So here we can see a pattern of recurring polygons that indicate to us that this land cover class is likely not naturally occurring. So what do you think these patterns indicate here? If you guess cropland, you are correct. These are actually rice fields in the country of Bhutan. So another example of where you may see patterns is in deforested areas. So deforestation can sometimes occur in a checkerboard pattern. And the last image characteristic that we want to use when interpreting imagery is called association, and that refers to how we observe how objects are related to their surroundings. So you can often rely on your lived experiences as well as your knowledge about the study area that you're looking at when using association. So for example, in this image, let's say we're trying to determine what land cover class this tan portion is in the middle here of this image. So we've been to the beach in our life, and we know that the ocean is usually associated with a sandy or a rocky beach. So if we can identify at the bottom of this image here that this land cover class is the ocean, which we can do from our other image characteristics, right? We've got white caps of the waves, and we've got the blue ocean. then we can come to the conclusion that this piece of land is likely a sand beach. So other types of association include the fact that roads are often associated with buildings and other urban spaces, and houses are often associated with other houses. So beyond these 7 image characteristics, there's other tips that can help you to interpret an image in Collectors Online. These include zooming out to gather contextual information about the image and help you apply this association skill, finding north, as well as getting a sense of scale for the image. So finding north will be pretty easy in Collectors Online because north is always at the top of the image, and this will be especially helpful if you have specialized knowledge about your area of interest and you can identify landmarks that may help you classify your specific assessment unit. As far as scale, Collectors Online will have a scale bar in the lower left-hand corner, and that will be really helpful in establishing the size of the objects that you're looking at. Another tip to help with image interpretation, especially if you plan to use things like synthetic aperture radar or false color imagery, is to get really familiar with the spectral response of the different land cover classes in your area of interest for all of these data before you start collecting data. Because understanding how different land cover classes reflect different polarizations of SAR or different false color wavelengths can help you leverage that data when distinguishing between 2 classes that may look very similar in optical imagery. And the final tip that we'll offer to you is that interpreting imagery is a less than exact science when we're working with open source imagery. So you may not have high resolution imagery during your time period of interest, which can be frustrating. So you may have to use high resolution imagery from a different time period using your Mapbox imagery and your Google Earth Pro, and combine that with low resolution imagery from your time period of interest using Planet NICFI or Sentinel-1 and 2. And then you have to use your best judgment to arrive at a conclusion regarding what land cover type is actually present during your time period of interest. And so this process is known as using a convergence of the evidence, where you use multiple observations of the different 7 image characteristics to arrive at a conclusion based on what land cover class is likely present during your time period of interest. And finally, there will be times in Collectors Online where even the Mapbox and the Google Earth Pro imagery are not high enough resolution and or clouds are preventing you from getting a good observation of your study area during the time period of interest. And for situations like that, we're going to want to use the flag plot capability of Collectors Online to discard that observation from our data collection process. Finally, here are the references that I used in creating this video, and that will do it for this video as well as for Unit 3. So now that you have a Collectors Online account as well as your own institution, you know how to create a project in Collectors Online as well as how to plan that project out, and you know how to interpret and import imagery into that project. So in our next unit, we're going to put all of that together and we're going to plan out our own image interpretation project in Collectors Online and then collect the data and make that project a reality. So that does it for this video, and thank you for listening. Collectors Online has received financial support from NASA, the U.S. Agency for International Development, or USAID, the Food and Agriculture Organization of the United Nations, or FAO, the U.S. Forest Service, Silvacarbon, Google, and the Spatial Informatics Group. It was co-developed as an online tool housed within the Open Forest Initiative of FAO. Collectors Online was initially developed by Servier and is now supported by a broad base of partners. And it was inspired by Collect Earth, a desktop software developed by FAO. The development team of CEO includes Arthur Lewes, Jordan Combs, Matt Spencer, Richard Shepard, Oliver Baldwin Edwards, Sif Beery, Roberto Fontanarosa, Francisco Delgado, Githika Tondapu, Billy Ashmall, Nishanta Kanal, John Dilger, Karen Dyson, Karis Tennyson, Cal Markert, Africa Flores, Emil Sherrington, and Eric Anderson. The Collectors Online curriculum was organized by Servier's Science Coordination Office, with individual models created by NASA, USAID, NASA's Earth Observatory, the Spatial Informatics Group, and Servier's Science Coordination Office. These individual modules were created by Crystal Wespestad of Spatial Informatics Group, Holly Rybeek and Robert Simon of NASA Earth Observatory, Billy Ashmall, and myself, Mickey Maganini, of Severe's Science Coordination Office. Review of the material was conducted by Severe's Science Coordination Office, including Kelsey Herndon, Emil Sherrington, Billy Ashmall, Deanna West, Katie Walker, Lauren Carey, Jacob Abramowitz, Jake Ramthen, Natalia Bermudez, Stephanie Melick, Emily Adams, Stephanie Jimenez, Vanessa Martin, Alex Goberna, Francisca Delgado, Biplab Bhandari, and Amanda Markert. Crucial insight regarding the development of the curriculum materials was provided by Claudia Paris and Andrea Puzzi-Nicolau. Review of the material was also conducted by Bart Kroll and Laura Cray of ITC, the Faculty of Geo-information Science and Earth Observation at the University of Twente. The course and unit banner images used in the course were created by Gianluca Ambrosi of ITC.